AISL 2024 October Paper 1. Question 1. A standard trigonometry question. Part 1. We need to mark the angle and the hypotenuse. Part B. Find the height. By Sokotoa, sine 36.1 is opposite over hypotenuse. Mark H to be the subject and calculate it by calculator. Question 2. Statistic question. Part A. Find the mean and SD of the test scores. The only thing we need to care about is the answers are in 4 significant figures. So, just need to input the scores and frequency into calculator. Part B. All scores are multiplied by 10. So the mean and SD would be multiplied by 10. Part C. Add 30 to all scores. So the mean would be added by 30 also. However, as the difference between the data and the mean doesn't change, the SD doesn't change. It is still 16.57. Question 3. Buying tickets. $8 for adults and $C for children. 7A and 60C is 832. 3A and 5C is 108. Make the simultaneous equations. And part B, solve it. Finally, if 1 to the nearest thousand is 203,000, what is the lower bound? Take half of 1,000 and use 203,000 to minus it. Question 4. A triangle is shown and the measurements are marked on the picture. We know all sides of the triangle and need to find the angle TRS. For the setting, we need to apply cosine rule to solve it. And we get 55.4. Part B. Find the area of the triangle. As we know one of the angles and the two sides next to it, we just apply half AB sine C to get 738. Question 5. We have a function of Canadian dollars, which is dependent on the days D. We can see that it is a linear function, so 60 is the slope. That means it is the daily rate of hiring a bicycle. And 10 is the fixed cost, so we just need to copy this. Part B. Find C when D is 5. So, just by substituting to get C5. Part C. We need to find the minimum of the days. We just need to read the question carefully and we will find the domain is already written in here. Part D. We have the inverse C of 1270 equals K. That means we just make C to be 1270 and D to be K. And we can solve it. Question 6. M is the mass of radioactive carbon and T is the number of years. It is represented by exponential function here. Part A. Find the initial mass. That means put T equals to 0. Part B. Find the mass after 20,000 years. So, just put T equals to 20,000. Part C. Find the smallest number of complete years it takes to become half of the mass. So, we set the mass function to be smaller than 60 and solve it by calculator. Question 7. Mass W is normally distributed with mean 8.9 and SD 1.2. We need to find the probability of the mass is more than 7.2. Just by calculator. Then we know that PW smaller than A is 0.1 and PW greater than B is also 0.1. Again, just by calculator, we can get the inverse function of normal. So A and B can be found. Part C. We need to try 2 times and see both of the hot dog's mass are less than 7.2. Since we have find the probability of W greater than 7.2 in part A, we just use 1 minus it and we can find the probability of less than 7.2. Then square it. Question 8. Invest 18,000 with 4% simple interest rate. The question reminds us it forms an AS. Part A. We need to find the common difference. That is just 18,000 times 0.04. Part B. After K years, the amount is greater than 32,000. So, we just write down the general formula for the sequence first, and then set it to be greater than 32,000. Solve it and we find the number of year is greater than 19. So, K is 20. Question 9. 60% passing rate for the students. 30 students in total. X is the number of students who pass. So, it follows a binomial distribution. The mean of a binomial distribution is just n times p. The variance is just n times p times 1 minus p. Part B. Find the probability that x is 21. By calculator again. Second part. Probability of x smaller than 12. That means x is more than or equals to 11. Be careful. The upper bound set to your calculator is 11 here. Part C. Mention one assumption. Test results are independent. Question 10. A regular payment question. What we need to do is just write down the terms we need to input to the calculator carefully. N number of terms is just 8 years times 12, which is the number of months. I interest rate, person value, PMT, PY, and CY. With all this, we get the future value. Then for B, just set FB to be 0 and find N. Question 11. We have a game. This is the number of points we get. A win scores W points. A draw scores nothing. A lose scores -7. Part A. We need to find P. Sum of the probabilities of all situations should be 1. So P is just 1 minus 0.35 and 0.4. Then, we played 60 times for the game. What is the expected number of losers? Just use the profit of lose times 60. Finally, we want to find W if this is a fair game. Expected value is just the sum of the values times their probability for all situations. Set the equation and solve it. Question 12. We have a curve and we want to find the derivative. Put the index in front minus the index by 1. Simple work. Part B. We need to find the slope at x equals 1. Just substitute x by 1 and get 19. Part C. We need to find the equation of the normal at this point. The slope of the tangent is just 19, so the slope of the normal is negative reciprocal. Then, we try to figure out the y-coordinate of the point when x equals 1. We know that the normal passes through the point 1, 2. Then we set the normal to be y equals -1 over 19x plus the y-intercept. By putting the point 1, 2 into it, we can find the y-intercept and thus the normal equation. Final question. Bacteria reproduce by dividing in 2 every 10 minutes. There are 1,250 initially. UN is the number of bacteria. We can see that this is just a GS, and the common ratio is 2. Therefore, we can write the general formula for UN first. Then, we can put 9 and K into the formula to find the missing values easily. Part B. We need to find N such that UN is 1.28 million. So, just set UN to be this and solve for N. Finally, we need to find the total number of divisions for the bacteria. It is more like an IQ question. Since the number of bacteria is increased from 1250 to 1.28 million, and every division will produce one more bacterium. Therefore, the answer is just the difference between the initial and final values.